Hello, good evening friends. We are here to know about organic chemistry, name reactions and basic of organic chemistry. I'll start with the basic two reactions. So let us see how we can solve them, right? And my second reaction is these two reactions are very important reactions as far as pharmacy is concerned. So let us see how we can understand them better, right? Now the first reaction is a reaction between formaldehyde and sodium hydroxide. And the second reaction is a reaction between acetaldehyde and sodium hydroxide. So we'll start with the first reaction, that is formaldehyde and sodium hydroxide. Formaldehyde, when react with sodium hydroxide, they react in this fashion. A first and hydroxide ion act as a nucleophile. This nucleophile attack to a carbonyl compound which is known as electrophile. Now the moment they will get attacked by hydroxide ion, this intermediate gets generated. Now, if you see a carbon is having two oxygen, is upper side and is below downside, right? But this is sp3 hybridized, fully satisfied with two bonds, but is having an extra non-bonded electron. So this hydroxyl group try to pull the electrons towards them. As a result, you get an expulsion of a hydride ion. So we can write the reaction further. Now, the hydride ion act as nucleophile. This hydride ion again can attack a second molecule of formaldehyde, and they can attack in this fashion. It's a nucleophilic addition reaction. Now, the moment they get attacked, they form this kind of structure. Now, look at the structure between this and this. Here you can find a carbon is having oxygen in the upper side and the lower side. But here the carbon is only in the one side, that is upper side. So, in this condition, nobody is pulling the electron towards them, right? So now this O minus require another hydrogen to fulfill their balance, fulfill their valency. So from where it can get one hydrogen. If you remember, the carboxylic acid, they are very stabilized in the form of resonance. So that means this formic acid, they can adopt this structure, that is a format and an H plus. As a result, this H plus will come and join the party over here, and we will get an alcohol like this. So we have a two major product. This is the product number A and this is the product number B. And remember, this is a format ion. So this ion will take up one sodium hydroxide Na plus and they form a sodium format. So in the first reaction, my product is sodium format, and as well as this alcohol, call them methanol. And this reaction is known as Cannizzaro reaction. Now this Cannizzaro reaction we have is a very important reaction that involved in pharmaceutical science. Let us talk about this reaction, which we call them as aldol condensation. So let us see how we can go ahead with that. Now this aldol reaction again contains sodium plus and OH minus, but this OH minus you will be thinking they will be attacking like this, but no, they are not going to attack like this. Why? Because this carbonyl compound is contain an alpha carbon which is having an alpha hydrogen. An alpha hydrogen is acidic in nature. This alpha hydrogen can be abstracted by the base and they can form an enolate ion with this structure. OH minus will take H plus and they form water. So you can get this enolate ions which is getting formed during the reaction. Now this enolate ion can attack another molecule of formaldehyde, which is getting attacked over here, and they form a typical structure If we look at these mechanisms, first enolate ion is coming and attacking this carbonyl compound, which is an electron deficient region, and the oxygen will take up one electron, and that's why you have an O minus. But how can we remember the H plus, which is being taken by sodium hydroxide just before the reactions? Okay. Now this H plus ion will be given to this, and they form a OH, and this product is known as beta hydroxy aldehyde, and that's why it is known as aldol. So that's all for today's class, and we have come to know two important reactions, Cannizzaro and aldol. So we'll meet you the next. Any queries, you just call us. Thank you so much.